Good afternoon, everyone. Welcome. My name is Mike Purdy. I'm the Executive Vice President for Research here at Columbia. It's my privilege to welcome you all here this evening to a World Leaders Forum focused upon what we learned from the Superstorm Sandy event of 2013. This evening also serves as the launch of the Columbia Initiative on Extreme Weather and Climate, a new coordinated research effort that is focused upon the understanding of risks to human life and property from extreme weather events, both in present and in future climate states. And importantly, then using that new understanding to develop better approaches to the mitigation of those risks. I want to say a few words about the breadth of this initiative and explain to you why I think it's so important. Its goal is to understand the creation, characteristics, and impacts of the full range of destructive atmospheric phenomena, be they droughts, floods, forest fires, hurricanes, tornadoes. I want you to understand why the university is supporting this wide-ranging effort and why we believe it's such an important opportunity for us to develop leadership in this particular area of fundamental science. This topic is about improving the quality of life for all of humankind. It's about resolving public controversies around the human-induced climate change debate. It's about improving the layman's understanding of the uncertainties associated with increasingly long-term predictions of extreme weather. I want to emphasize that at the foundation of our ability to make a contribution here, a contribution of meaningful significance to society, is the physics and the math that allow us to describe quantitatively the dynamics of these wonders of nature in our planet's atmosphere. The development of improved understanding of these dynamics has been stimulated by new observations over the past decades, enabled by technological advances in sensor systems in the marine, atmospheric, and space environments. Increased computational capabilities have built upon these new process-oriented insights to produce meaningful predictions that can be tested and refined. All this has developed within a research program at Columbia led by the faculty and staff of Lamont Doherty Earth Observatory, who have for decades been at the forefront of climate research. So here we have a confluence of factors that are the ideal basis for a successful research program. Established world-class expertise and well-identified intellectual leadership, technological advances that are revolutionizing observational capabilities, and these in turn are feeding the construction of more effective simulation techniques using the rigorous mathematics that underpin atmospheric dynamics. If our goal is to improve the quality of life for our nation and for the world, then we must also think about how to make this newfound comprehension of the atmospheric dynamics of practical benefit. How can we impact policy decisions and engineering designs? How can we change human behavior? Because we are Columbia, we have great intellectual capacity in all these fields, in policy, in law, in economics, in engineering, capacities that are integrated under the umbrella of our uniquely capable Earth Institute. So here we have a very special opportunity. As a university, we have chosen to focus upon the right problem at the right time, I believe. In so doing, we have a golden opportunity over the next 1 or 2 decades to revolutionize humankind's response to and readiness for catastrophic weather events. This is why I'm so pleased for this opportunity to be here this evening and recognize the creation of Columbia's Extreme Weather and Climate Initiative, and to thank the faculty leaders for all their efforts in bringing this research the visibility and priority it deserves. And with that, I hand the podium over to Adam Sobel, the intellectual leader of this effort, who will tell you about the specifics of the program and the plan for this evening. Thank you all.
Thank you, Mike. Thank you, everyone, for coming. When Hurricane Sandy hit 2.5 years ago, in late October 2012, it was an awful disaster, as we all know. But like many awful disasters, it was also cathartic and transformative. We learned many things from Sandy, both the storm itself, the disaster that followed, and the recovery and rebuilding in its wake that continues today. And when I say we, I mean several different meanings. The public as a whole learned just how vulnerable our city and state and the whole region was, just how profound the harm a single storm could inflict. But scientists and some government leaders had known the vulnerabilities of the city and the region for a long time, at least in its broad outline. It was clear that New York could possibly get hit by a serious hurricane, one worse than any in recent historical memory, that many low-lying areas would be flooded and more or less destroyed, and that this would pose serious risks to the infrastructure of all kinds. For example, that the subways would flood was known pretty precisely due to the work of Klaus Jacob at Lamont and George Diodatis at the engineering school here in several reports put together for the city and state by groups led by Cynthia Rosenzweig of NASA and Columbia. But those risks weren't understood by the broader public until late October 2012. Even we scientists, of course, didn't know everything. We couldn't have predicted in detail all the things that would fail and how badly and what it would take to fix them, nor the details of the storm itself, which was extremely unusual and unprecedented in many ways in modern meteorological history. So in the weeks and months afterward, there was a lot of discussion and action by city, state, and federal government, as well as academics and people in key industries, insurance, energy, housing, transportation, to try to learn from Sandy and figure out how to make the nation and the region and the city more resilient for next time. There was a great amount of media coverage. A lot of it was very good, as the whole region seemed to be going through a soul-searching exercise. I was interviewed by a lot of reporters during that time and asked to speak in the months afterwards to non-scientist audiences much more than I had done before, and everyone was profoundly interested in what I had to say as a scientist, given the disaster that had just affected all of us. And this was a very new experience for me, and it caused me to understand in a more visceral way than I had before that the science that we do here, my colleagues and I, had a greater relevance to the real world than I had understood, even though on some intellectual level I'd known it. And of course, it wasn't just me. Many academics from the region were speaking to the press and in many other forums, constructing the narrative of what had just happened and what it meant, and many of those were from here, Columbia University. So the spring after, I organized an impromptu graduate seminar course, the spring semester of 2013, about all the dimensions of Sandy. And we met twice a week, and almost every meeting featured a different guest speaker on different topics, from the meteorology to climate to the subways to insurance to beach erosion, disaster response. And many of the speakers were from outside, and some from government agencies, but many of them were from inside Columbia's walls. There were many more Columbia speakers that I could have had, but didn't because we didn't have enough weeks in the semester, and it was really remarkable to see the intellectual firepower and the depth of the expertise and experience and talent that we had here that was relevant to this singular event. And this was just one event. It was a hurricane hitting New York. We had a seminar about some other type of event in some other place, some other extreme weather event or climate phenomenon, the list of outstanding potential speakers would have been much longer still. Sandy raised many questions about risks of new severe weather events in the future. As we think about those risks, climate change naturally looms large. We know some of the ways that global warming will make us more exposed to extreme weather, more heat waves, increased risk of flooding as the sea level rises, for example, But with other questions, such as how hurricanes or other severe storms, tornadoes will change, the science is very open. But what becomes apparent very quickly, as one thinks about all these kinds of severe weather events, is how great an intellectual contribution Columbia scholars are making. The number of outstanding scientists and intellectuals of all kinds here doing groundbreaking work on understanding all kinds of severe weather events, their connection to climate, and their impacts on human society, very importantly, is itself extreme. In the news last week were many stories about a paper by Jason Smerdon at Lamont and Ben Cook of GISS showing the probability of much more severe droughts for the Southwest than any in the past. And this followed a report lead authored by Richard Seeger of Lamont a couple of months earlier, written for NOAA, explaining the causes of the current California drought of the last 3 years. Just last week also, the New York Panel on Climate Change report, which we'll hear about in a few minutes, had just came out with contributions from several Columbia and NASA GISS scientists. And those are just examples selected by the media in the last couple of weeks. I could also cite the work of Michael Tippett on making longer-range severe weather forecasts, including understanding how El Niño events change tornado and hail risk in the US, so that even seasonal forecasts of these phenomena might be possible, something that isn't done now. Ben Orlov and others at CRED understanding how people make decisions in the face of forecasts of extreme events in SIPA, the School for International and Public Affairs. Tim Hall's work also at GISS on hurricane risk, work at the School of Public Health, especially Erwin Redlener on the most vulnerable populations in disaster, Jeff Shaman on how epidemics are mediated by climate extremes, work by Michela Biasuti at Lamont and Alessandro Giannini at the IRI on drought in the Sahel, how it'll change in a warming climate and what that means for agriculture and water resources, or work at Season, led by Mark Levy and Bob Chen, on understanding the coupling of development and disaster risk of all kinds globally. Umana Lal and others at the Water Center in the Engineering School on how supply chains are disrupted by floods, such as happened in Thailand in 2010. Or many, many more examples I could give, and I'm intentionally excluding some of the ones of our panelists, which you're going to hear about in a moment. At the same time, even with all this remarkable intellectual achievement here, the potential is even greater than what's been realized. The potential for all the research projects I just described to make further advances is much greater than has been realized yet, especially if we can learn to draw new connections between the physical science and the human dimensions. The need for this research is great and growing. Not only is the climate changing, but other factors are changing and increasing the risks we face as well. Deaths and economic losses from natural disasters are increasing much more rapidly worldwide than climate change alone can explain. Population growth and economic development in high-risk areas are putting more people in harm's way. The need for understanding and predicting these risks and developing strategies to make people and infrastructure safer is growing daily. The challenge is complex because of the tightly interconnected nature of modern societies, with long supply chains and the possibilities of cascading failures, as we saw during Hurricane Sandy. One has to understand the natural phenomena and the human ones scientifically at the same time, and this calls for a greater degree of integration than we have seen yet, maybe even a new science of extreme events. So in the 2 years since Sandy, a group of us, as Mike described, have formulated an idea that we could do something new on this theme by drawing together the many strands here at Columbia. So with the support of the Executive Vice President for Research, from whom you just heard, the Earth Institute, the Lamont Doherty Earth Observatory, we're here tonight to announce the formal beginning of that something. We have a web page, which just went live today, extremeweather.columbia.edu. And on it, we have a mission statement, whose first paragraph reads, "The Columbia Initiative on Extreme Weather and Climate is focused on understanding the risks to human life and property from extreme weather events, both in the present and future climates, and on developing solutions to mitigate those risks. The initiative engages the broad and deep expertise that exists across Columbia University on all dimensions of this problem. With partners in the private sector, government, and academia, we work towards the goal of greater societal resilience to extreme weather and climate. Our focus is global. Tonight is about Sandy, since we do live here in New York, and this event had such an important role in changing many of our thinking. But this will probably be the last event we do about Sandy, although I suppose one should never say never. And even in our discussion in a few minutes, my hope is that we can draw out some lessons with global applicability, even as we talk about our own local disaster. Our scientific expertise here at Columbia is not limited to New York. Our strength is in thinking about this problem from a global perspective, and that will be how we orient this initiative. What is an initiative, you might ask? It's a word that has no formal meaning in the university's structure, administratively, that I know of, and that's intentional at this point. We're keeping it light and simple for now, with a minimum of administration. And at this point, the formal activities of this initiative will consist mostly, although not exclusively, of events, of which this is the first. Just to mention one of the others, on May 6th, we'll have our first science workshop, one day, featuring talks by about a dozen Columbia faculty to demarcate the intellectual turf that we're staking out here. In September, we'll have a workshop on monsoons and more to follow. Besides those larger events, we'll have many smaller ones, some as modest as having a colleague from one department speak in the regular seminar series of another who might not normally do so, to keep an ongoing discussion across disciplinary lines. And the goal here is to make the connections we need to allow us to do collaborative research that we might not have done before. This initiative will also support, in a seed way, a very small portfolio of highly focused research on extreme weather and climate, and this is where the real growth potential is. The initiative will become more than an initiative, maybe a center or some other structure doing new research above and beyond all the great work that exists here now, to the extent that we find partners who are willing to work with us and collaborate with us to define and meet the intellectual challenge posed by extreme weather risk. The scope and complexity of these challenges require some innovative funding sources in an atmosphere where federal funding for this work is level or retracting, while at the same time the need to increase our understanding of the problem is growing. The investment that would be enough to make a huge impact in this initiative would still be small in comparison to the potential costs in lives and property lost and disruptions to commerce that can be averted by better understanding and mitigation of extreme weather risks. So for that reason, we're looking to partner with individuals, corporations, and foundations who appreciate the unique potential that we have here through Columbia's interdisciplinary approach, with Lamont, the Earth Institute, the Engineering School, and other units, School for Public Health, Law. I'm not naming them all, but they're all on our webpage, to improve our understanding of the changing risks. Just to give one example, before I close and introduce our panel, of the kind of research we can do is to estimate the risk of a hurricane yet more extreme than one that's ever struck New York or any other vulnerable place in known human history. In most cases, in most places, the worst case scenario has not been realized yet. And that's just because of the shortness of records. If something's truly rare, then recorded history may be too short to have seen it. And on top of that, the climate's changing, which is making the probabilities of an extreme event change, of course. And this means that we can't use historical data to estimate the risk accurately. And so, doing so, asking whether a Category 4 hurricane, say in New York, is a 1 in 1,000 or 1 in 10,000 or 1 in 100,000 year event is a cutting-edge modeling problem. What's the worst storm that could happen? What would the winds and storm surge and rainfall do? And what would the consequences be if it did, here or anywhere else that such a thing is possible? How should public planning account for these risks? How should an environmental impact statement, for example, be written when a large construction project is being undertaken? to account for the risks? What are the most cost-effective, but still effective, infrastructure measures in transit, power, housing, or any other critical area to keep our city or any other from breaking down in the next disaster? How should insurance policies be written to discourage risky investment while being equitable and fair to people already in high-risk areas? And what are the right financial instruments to mitigate disaster risk? So with that, I want to give you a more direct experience of the kind of intellectual leadership you can find on this topic here at Columbia by introducing our panel. We have 3 distinguished Columbia scholars and a leader from New York City government who we're thrilled to welcome as our guests here tonight. And I want to invite them up here on stage with me, and then I'll introduce them one at a time. Okay, all the mics work, fantastic. I'm going to start immediately to my left with Daniel Zerilli. Daniel was appointed in March 2014 by Mayor Bill de Blasio as Director of the Office of Resiliency and Recovery for the City of New York, leading the implementation of a stronger, more resilient New York, the city's comprehensive climate resiliency program to strengthen coastal protections, upgrade buildings, improve infrastructure, and make neighborhoods more safe and vibrant. It's a remarkable document, actually. I recommend everybody to read it. It's only 400 pages or so. Daniel was appointed in 2014 to a 3-year term on FEMA's National Advisory Council and is serving on the Resiliency Technical Advisory Panel for the State of Louisiana's 2017 Coastal Master Plan Update. From February until December of last year, 2014, he also served as the acting director of New York City Mayor's Office of Long-Term Planning and Sustainability. Before that, he was named the city's first director of resiliency in June 2013, after serving on the mayor's special initiative for rebuilding and resiliency, leading the city's post-Sandy efforts to develop a comprehensive coastal protection plan for the 5 boroughs. In a previous role, he was the Senior Vice President for Asset Management at the New York City Economic Development Corporation. And prior to that, he spent 5 years with Bechtel Infrastructure Corporation. He's a professional engineer in the state of New York and holds a Master's of Science in Civil and Engineering from MIT and a Bachelor's in Civil Engineering from Lehigh University. And he lives in Staten Island with his wife and 2 children. To Dan's left is Lisa Goddard, the director of the IRI and an adjunct associate professor with the Department of Earth and Environmental Sciences of Columbia University. IRI, I should spell out, is the International Research Institute for Climate and Society on the Lamont campus. Lisa has been involved in El Nino and climate forecasting research and operations since the mid-1990s. She has extensive experience in forecasting methodology and has published papers on El Nino, seasonal climate forecasting and verification, and probabilistic climate change projections. Currently leading the IRI's effort on near-term climate change, she oversees research and product development aimed at providing climate information at the 10 to 20-year horizon and how that low-frequency variability and change interacts with the probabilistic risks and benefits of seasonal to interannual variability. Most of her research focuses on diagnosing and extracting meaningful information from climate models and available observations, and she also developed and oversees a new national postdoctoral program, the Postdocs Applying Climate Expertise Program, or PACE, which explicitly links recent climate PhDs with decision-making institutions. She sits on 5 scientific advisory panels and co-chairs 2 working groups, and her PhD is from Princeton in Atmosphere and Ocean Sciences, and her bachelor's from Physics from UC Berkeley. To Lisa's left, and your right, is Michael Gerard, Andrew Sabin Professor of Professional Practice at Columbia Law School, where he teaches courses on environmental and energy law and directs the Sabin Center for Climate Change Law. He's also Associate Chair of the Faculty of Columbia's Earth Institute. And before joining Columbia in 2009, he was partner in charge of the 110-lawyer New York office of Arnold & Porter, LLP. He practiced in environmental law in New York City full-time from 1979 to 2008 and tried numerous cases and argued many appeals in federal and state courts and administrative tribunals. He formerly chaired the American Bar Association's 10,000-member section of Environment, Energy, and Resources, and he served as a member of the executive committees of the boards of the Environmental Law Institute and the American College of Environmental Lawyers. He's the author or editor of 11 books, 2 of which were named Best Law Book of the Year by the Association of American Publishers, and the most recent one is Global Climate Change in U.S. Law, which just came out last year. And to Michael's left is Dr. Radley Horton, an associate research scientist at the Center for Climate Systems Research at Columbia. Radley was convening lead author for the 3rd U.S. National Climate Assessment. He's deputy lead for NASA's Climate Adaptation Science Investigator Working Group, charged with linking NASA's science to its institutional stewardship. He serves as the climate science lead for the New York City Panel on Climate Change and is currently a co-lead for the NOAA-funded Consortium for Climate Risk in the Urban Northeast. Radley is also the Columbia University lead for the Department of Interior-funded Northeast Climate Science Center. He's been a co-leader in the development of a global research agenda in support of the United Nations Environmental Programme's Program on Vulnerability, Impacts, and Adaptation initiative. He's the principal investigator on an NSF-funded climate change education partnership project, and he also teaches in Columbia's Sustainable Development Department. So those were a long set of CVs, but I want you to know who you're hearing from today and just the depth of the talent that we have. So we decided for the format to dispense with introductory remarks and go straight into questions. So what I'm going to do is ask a question of each of our panelists and let them answer it, and then we'll take it from there, and I hope that we'll have discussion. And I want to start with Dan as our distinguished guest from outside Columbia, who we appreciate coming very much. And Dana, what I'd like you to talk about in any way that you think is appropriate is to describe your experience as a government agency head with a very practical job to do, helping the city recover from this disaster and be better prepared for the next one. In that process, I want you to describe your experience working with scientists from academia, because after all, that's what we're trying to do here. And within the context of any of the different initiatives that you are involved in, whether it's trying to fix liquid fuel supply lines or transit or electric power, what has worked well in working with academic scientists and what is not? And what are the challenges, whether they be intellectual challenges or institutional or administrative or any way that you want to answer that?
Great. Thank you, Adam, and thanks everyone for coming out here today. I guess I just want to start a little bit about the city's efforts. We've been at this since the storm, of course, for a little over 2 years, but the city has not been, certainly wasn't the first time that we as a city have been thinking about the risks of extreme weather and in particular climate change and a broad range of climate risks. One of the great things that happened over the past several years was the creation of the New York City Panel on Climate Change, which Radley, of course, sits on, and I was delighted to share the stage with them last week as we released our most recent report. That's something that started in 2008 when the city knew it needed to begin thinking more seriously about climate change and the impacts it might have on the city, to advise us on what those impacts might be and how we should respond to it. But nothing like a great storm to bring money to a problem. And so Sandy hits, and now the work that we've been thinking about for several years, we could put into practice because the federal appropriations bill that came from Hurricane Sandy, the $60 billion bill, a good chunk of that coming into the New York City region, was going to demand that we actually had a plan for how to spend it. And so calling the New York City Panel on Climate Change back into service, the city set up the Special Initiative for Rebuilding and Resiliency, really to think about this from a couple different ways. One was learning what just happened from the storm and getting past all the anecdote and understanding really what the impacts were on our infrastructure systems, how the networks performed, how they failed, how those failures propagated through the different systems, and really understanding what Sandy was, because there's a lot of, the anecdote, either only takes you so far or isn't quite accurate, and you learn that through the analytical rigor of going through the analysis. But then we knew it was important for us to take a step back and say, Sandy was just the last thing that happened, but it's certainly not the next thing and certainly not the only thing that could happen here, and we needed to take a wider range of risks. So that's where the New York City Panel on Climate Change and our partnership with academia really came to bear as we were able to look at what the projections for climate change here in the region were going to be, whether it's coastal storms, sea level rise, heat, precipitation, a broad range of climate risks, and really understanding the uncertainty that comes with those projections. And I think that's almost the name of the game here, is the uncertainty, and being able to describe that in a way that makes sense and to be able to react to it is really important. You know, the news last week of the high-end projections of sea level rise in New York City might reach 6 feet by 2100. Of course, everyone's going to focus on that number, but you know, that's the high-end projection. That's the 90th percentile in the model ranges. But there's also a mid-range, and then there's also a low range. And so when it comes time to actually picking how do we adapt our city, well, what number do you pick when you're thinking about what structure you're going to build, or what how you're going to react in some way? So being able to work with in partnership with academia to be able to describe that uncertainty and think through what it means is an incredibly important thing. And so we, as a city, issued that report, 438 pages, to be too precise. Lived that a little bit too closely. Really laid out a strategy for how we as a city are going to take the science from a broad range of climate risks and apply it here in New York City to make ourselves stronger and more resilient to a wide range of risks. It's things like strengthening our coastlines, and we're working with the Army Corps to put sand on beaches and improve our natural infrastructure and wetlands, and it's a green and gray infrastructure solution across the harbor. But we're also realizing that just because Sandy hit and it was a coastal storm, it doesn't mean all of our investment should be in our coastal defenses. We need to make sure that our buildings are upgraded. We've passed 16 pieces of legislation to upgrade our building code here in New York City. We're upgrading our zoning code, and we're doing a lot of land use studies. But then we're also looking at our core critical infrastructure, whether it's our power grid and the $1 billion that Con Ed is making investments into to better handle not only coastal storms, but also make it more reliable and resilient for heat waves and other strains on the power grid. And that sort of thinking then goes through into our telecommunications system and into our liquid fuels network, where we have a very strong partnership with the Center for Global Energy Policy here at Columbia, and thinking through the unique challenges of that network of infrastructure assets. And then also taking it out of the physical, we're also looking at very much into the social and economic resiliency measures that need to be taken into account. And it's things like flood insurance reform and the changes to the National Flood Insurance Program that need to happen for both risk reduction as well as for affordability, and land use changes that we need to consider going forward into the future. And so there's a broad range of things that the city's doing, and all of it is supported by the best available science, really, that's represented by the New York City Panel on Climate Change and is served by many of the Columbia professors that are on that panel. And so we couldn't have done, so the city has done a lot. We're certainly safer than we were when Sandy hit, but we're not safe by any means, and there's a lot more that we need to do, and there's going to be a lot more investment to continue to make the city safer, stronger, more resilient. But all of it is grounded in that best available science, and we're going to continue to look towards academia and folks like Bradley and his colleagues to continue to advise us on how we can best make the city prepared for the risks of the future.
Thank you. So as long as we're talking about the New York Panel on Climate Change, I think we should go out of order and ask Bradley a question, since he's directly involved in that panel. So the question I want to ask Bradley is, and you can answer this in as open-ended a fashion as you wish, you've been involved in this activity for a number of years, the consultation with the city that Dan just described. And so in the years that you've been doing it, how has the way these reports have been received changed, if it has changed? And have they had the impact you've hoped for? Or in any other way you want to describe your experience interacting with government as an academic scientist?
Great. So, you know, I've been involved, I guess, through the New York City Panel on Climate Change since about 2008 or so in its first configuration. But really, New York City's efforts to understand its climate risks go back to 2000 or so. I think in 2001, the Metro East Coast study came out. I see Klaus Jacob in the audience, who was an active member of that. That was led by Cynthia Rosenzweig, who can't be here tonight. So really, New York City has embraced the science, I would say, since at least 2001. Right through the first New York City Panel on Climate Change. One thing that I would say characterizes New York City's response is comfortability with talking about the risks, something we don't always see everywhere in the United States and other parts of the world. Embracing the science, and also, as Dan alluded to, comfort with the uncertainty. You know, I think that there's a tendency sometimes in some circles to use uncertainty as maybe a crutch to avoid action. We don't see that in general within New York. I think New York City is used to real long-term planning. Fundamental uncertainties are a big part, of course, of all long-term planning. So I think there's a tendency not to get hung up on climate uncertainties and to understand that that's sort of the nature of the work. So once you accept that uncertainty, I think you can move on to those actions, those adaptations that maybe make sense even if climate change doesn't end up being as bad as it might be, as well as thinking about particular flexible approaches to adaptation that give you a lot of routes and options, whether sea level rise ends up being 2 feet this century or 5 feet. So those would be a couple elements. I would say since the city, certainly before Hurricane Sandy, and Dan, I'm interested in your thoughts on this, was very actively addressing climate risks. Thinking about sectoral approaches to some of the impacts, and things were really moving forward. I think Sandy probably, by highlighting the vulnerabilities to everybody, upped the gear, upped the speed at which a lot of those actions were happening, and probably also pointed towards some new strategies. But I think it's important to highlight New York's leadership and the fact that it wasn't just talking about the risks, but adaptation strategies were underway, as was greenhouse gas mitigation efforts, even before Sandy. So I think that's a key part of New York City's leadership that goes back several years. And of course, the United States and the world look to New York City for leadership. We need to, I think, keep that in mind. The outsized impacts, both in terms of the mitigation side and the adaptation side, that New York's leadership can have, I think are key points.
Yeah, I mean, one thing that struck me, just to comment on that before we get to the next question, is as I was reading all the media coverage in this sort of 6 months after, where the New York Times and many other outlets were writing so many stories about Sandy, was the fairly enlightened nature of the discussion around climate risk. And it seemed to me that a lot of that was the foundation laid by all those reports, all that work done with the city, that the idea of we learned a lot from Sandy, but a lot of it was sort of known already because of that.
Could I maybe one more follow-up point to that, if I could? How much the interaction with the city's expertise and decision makers has advanced the science to helping us really understand what are the climate metrics that matter the most to the city? Is it days over 90 degrees? What level of a heavy rain event causes the most problems? By having those kind of interactions with all the city's expertise, it really helps us advance the science as well. So it's really a two-way interaction.
Okay, on that theme, I think the next question that's right to ask is of Lisa Goddard, whose work at the IRI is very much about interaction with the users of climate information and using their needs to drive research, which is what Radley just said. But I want to ask a slightly more specific question. It's not really very specific. And that's about, your role here is as our globalizer, so that this isn't just a New York discussion. And so the question is, are there any lessons you see in what happened to New York City in Sandy that are relevant globally, or vice versa? And you can answer that either in talking about sort of short-term emergency response or long-term adaptation and recovery, and either about things that went well here that might not have gone as well elsewhere, and if so, how they could get up to New York's level, or vice versa, if they're things that are known elsewhere that we could learn from here. Any way you want to answer
Okay, I think I'll sort of take all of the above. Yeah, I think that there are a lot of lessons that are really shared between New York and other parts of the world. The IRI works primarily in developing countries, not entirely, but primarily. And the difference is pretty stark in those settings. The data, the information that exists in a place like New York is staggering. We have access to information at our fingertips any time of the day. That often doesn't exist in other parts of the world. We also have engineering infrastructure that doesn't exist even in many parts of the United States. So all of those things would seem to really secure us. And to some degree, some of the engineering and infrastructure becomes a little bit of a maybe false security. And we really saw in Sandy the value of the information that came in, the preparedness that afforded was really, really important. And so in developing countries where they don't have the infrastructure, the dams in the right place to prevent flooding events in villages, for example, having that information in a timely manner is critical. But I think we also saw that even in New York, there were a number of incidents, a number of examples in the infrastructure that exists that wasn't sufficient to the types of events like Sandy, which is an extreme event. It's rare. But I think it underscores the point that we're never going to make ourselves completely climate-proof. We do need to do what we can where we see quantifiable risks, but we also need information that can inform us in real time, whether that's the next few days or the next season or the next 10 years, depending on what time scale you really need to make your decisions. And so those lessons are equally applicable no matter what the setting.
Okay, thanks, Lisa. So the last of my 4 questions is, before we go to a more open discussion, is for Michael Gerard. And it's, again, a broad question. And the question, Michael, is how can we use the law, which is your particular instrument, to make our infrastructure, whether it be physical or otherwise, more resilient against both extreme weather events and climate change? And how does what are the relative strengths compared to other instruments we might use, or the complementarity between legal and other approaches, and if you want to answer specifically to here in New York or more globally, as you wish.
So there's an emerging body of law that's requiring the consideration of future climate risks in the planning of infrastructure and other physical projects. The National Environmental Policy Act was first enacted in 1970, the first major statute of the major modern environmental statute in the U.S., and it requires the preparation of environmental impact statements for major federal actions that could require that could have a significant effect on the environment. The statute also created the Council on Environmental Quality as a unit within the Executive Office of the President to promulgate the regulations and guidelines under the statute. Just this past December, the Council on Environmental Quality proposed guidelines on the consideration of climate change as part of the environmental impact statement process. And in addition to talking about how greenhouse gas emissions from projects, both direct and indirect, should be considered in the review process, it also said that environmental impact statements should consider the effect that climate change would have on projects. So if you're the Federal Aviation Administration and you're reviewing the proposed expansion of an airport runway, it's relevant to think about, is that runway going to be underwater during the useful life of the project? And it's advancing the general thought that in environmental review and in permitting in general, we should look not only at the conditions that will exist at the beginning of the useful life of the project, but also at the end of the useful life of the project, so that we can adjust the siting or design or other aspects of the project accordingly. The city of New York in this area, as in so many other areas, is really ahead of the curve. There is in New York a state analogy to the federal statute, the State Environmental Quality Review Act, SEQRA. And the city's technical manual for the implementation of the city's review of that state statute has for some years called for the analysis of the effect that climate change may have on future projects. So it has now become common for environmental impact statements prepared in the city on city lead projects to systematically look at that And as a result, we've seen a number of measures that have gone into the design of projects. In some instances, they identify a risk and they put the critical infrastructure at an upper level rather than a lower level. In some cases, they have waterproofing around the building. In some cases, they've actually planned to bring in fill and raise the elevation of the land on which a project would be built. So all of this planning can greatly improve the resilience of the city. This past September, Governor Cuomo signed into law the Community Risk and Resilience Act, which is a state-level statute that is requiring the State Department of Environmental Conservation to come up with projections about sea level rise and revisit them from time to time as the science emerges, and for those projections and other projections to be considered by state agencies as they go about their permitting and financing and planning for infrastructure projects in the city. Once this gets going, we're going to see a lot of additional activity, and that is making the state one of the leaders nationwide in applying these requirements. So these are all instances where the scientists come up with the projections. The scientists, like the people Lisa works with and the people Radley work with, come up with the projections of what future conditions will be, and these legal mechanisms plug those projections into the governmental decision-making processes and also private decision-making processes. The final thing to say is a word about insurance. In a world where you didn't have governmental restraints and so forth, the insurance industry would play a central role in guarding against these risks, because after all, the insurance industry are in the business of quantifying risks and seeing what are the probabilities and severity and so forth. That is happening to a certain extent, but we have a perverse outcome as a result of the National Flood Insurance Act, which provides a subsidy essentially for the continued development in flood hazard areas. The National Flood Insurance Program relies on maps that are issued by FEMA, and FEMA's maps have looked only at past conditions. They do not look at future projections. And so a flood hazard area on a FEMA map is because of the past, not the future. A couple of years ago, Congress amended the statute to try to reduce some of the artificial subsidies that the statute provides for the development of flood hazard areas, and also to require FEMA to start considering sea level rise in its flood mapping program. The intent of the statute was to cause a rise in flood insurance rates to more closely reflect what the market would be. When it started to have the effect of causing a rise in flood insurance effects to more accurately reflect what the market would be, there was a public outcry, and Congress postponed the application of that, and the president signed it. So one of the few positive things the last couple of Congresses have done with respect to climate change was undone. FEMA is still now looking at developing the scientific techniques to reflect future sea level rise in its mapping. Once again, the city is really ahead of the curve and has been looking at that systematically for some time. But hopefully, in time, that will happen, and the insurance industry can become a more efficient regulator in its own way of these impacts. Thanks.
So after hearing these four answers, I have many more questions than we have time for, but and I have one in particular that I wanted to ask, but the discussion of FEMA and NFIP begs for more discussion. I think we could talk about NFIP all night easily, but let's just focus on the FEMA flood maps. And so this is a science question for everyone, and also a sort of policy and politics question, maybe for Dan. What's the right way to make flood maps that incorporate sea level rise? In other words, given the fact that we have, if you want to account for sea level rise, on top of all the current maps are based on historical data. Even with that, there's some uncertainty in what's the 100-year flood or the 500-year flood. But the uncertainty around the projection of sea level rise is a qualitatively different kind of uncertainty. And so the question is, what's the right way to do that? Why is it hard? What could we do better on this? This is a question for anyone who wants to answer it. But I guess I'm curious to hear Dan's thoughts especially.
There's a lot to talk about with NFIP, I suppose. As we've looked at NFIP and the slowdown in the rate increase happening with the most recent the Homeowners Flood Insurance Affordability Act, really I think what that's trying to do is buy some time in order to sort out some long-term issues. I don't think anyone would argue that we need to continue investing in risk reduction across our coastal communities. The rates that we're going to hit people hard. And remember that the Bigger Waters Act that passed in 2012 passed before Sandy, and so it would be really interesting to imagine a world in which those rate increases and map updates were happening outside of Sandy. It's sort of a thought experiment, perhaps, on what sort of outcry we could have seen and whether it would have been even more confusing for people going through it. But ultimately, the city wants to see risk reduction, and safer neighborhoods. Insurance and pricing of that risk is a key part of that. It's not always clear to us as the city that FEMA knows how to actually price that risk. And so there's a number of elements of uncertainty here that happen. One is the arbitrariness of the 100-year floodplain as a line. You're either in it or you're outside of it. The work that we've done with the New York City Panel on Climate Change to show the extent of flood maps in the future with sea level rise and the city's actions to adopt maps that aren't even effective yet for insurance purposes into the building code already with freeboard built in to account for future sea level rise is really a measure of the city wanting to continue to build to future standards and continue that adaptive pathway. But at the same time, homeowners in many vulnerable communities are going to be hit hard by insurance rate increases, and there's an affordability challenge there that has yet to be addressed fully by Congress or by FEMA, and the city's doing some work to understand that challenge. We commissioned RAND and others to look at the 1 to 4 family segment. We're doing some work on multifamily. We really want to understand what those affordability impacts are going to be so that we can devise the right policy approach to that. But it's the arbitrariness of the 100-year floodplain, which is a challenge, the uncertainty in sea level rise, and that compounds itself to create a really tough story to describe to the public. But that hasn't stopped the city from taking action to adopt those most recent flood information into the building code. We're looking ahead for sea level rise already. That's already baked into the code. So we're doing some of those things already to anticipate where that's going, regardless of where that map update process is going. The only other point from all this that I want to make is that, and I'll take off the NFIP just for a second, and we can go back to it. All of these projections and uncertainty that we're talking about and sort of tend to wring our hands over a little bit, it all assumes that we don't act. And I think the other good news coming out of all this is that the city continues to act not only on the resiliency front and to invest in risk reduction, but also to reduce our own contributions to the causes of climate change itself. And we've committed, and we've become the largest city in the world to commit to the 80 by 50 standard and 80% reduction in greenhouse gas emissions by 2050. We've already put $1 billion on the table in order to make investments in the city's municipal building infrastructure. Buildings we know account for about nearly 3/4 of all of the greenhouse gas emissions here in the city. And so by taking a hard look at making our buildings more energy efficient, we want to make sure we're reducing our own causes to the climate change challenge and also showing others how it can be done. And I think we in New York City see it as we have a unique, it's a unique role in the world that people do look towards New York City for leadership, and we need to show how we can do both things, mitigate our own contributions, but also adapt our city to the risks of the future. And insurance, certainly, to take it back to that, is certainly a piece of that puzzle and risk reduction that we're going to continue to work with FEMA to make sure that we are seeing the right level of hazard information, and that we're taking that information and applying it in the right way, as we've already done to upgrade our building code, for instance. So.
Yeah, so, Radley has something to say.
Yeah, so just I think in terms of our charge as scientists, and also for some people who are sort of intermediaries in communicating with the public, It's important to highlight also in the sea level rise issue. I mean, one view is to think of the map, the kind of spatial representation. The other element that can be very powerful, and I think is underappreciated, is focusing on a specific place and talking about how sea level rise alone can change the frequency of flooding in that space. So if we talk, for example, about 2.5 feet of sea level rise, something which is probably towards a high-end projection certainly towards a high-end projection for the 2050s, but that same 2.5 feet is actually a pretty middle-of-the-road projection probably for the 2080s. So just to highlight how that sea level rise alone, even if storms don't change at all, right? So we don't have to invoke stronger hurricanes, stronger nor'easters, just the storms we've had in the past, if they occur with 2.5 feet of sea level rise, turn the 1-in-100-year event into something that happens roughly once every 20 years. That, I think, is something that maybe is underappreciated and that maybe viscerally to 100 years, maybe I take a chance on that. But if this is something that could happen on average once every 20 years in the future, that's within the lifetime of the typical mortgage, some typical investment decisions. So, whatever the decision is, I think that you're just getting at that communication role. And, as we're advancing the science, we also have to think about the best ways to communicate this information in ways that people can use it, but not maybe be paralyzed by it as well.
Right. But I still want to, maybe I'm obsessed by the science problem, but if we, let's say we could, FIP is partly, as Michael said, that, we may not be, given, if we knew the risk, we still wouldn't be pricing it right? That's the problem with NFIP is basically that. But what about the problem that we don't know the risk? I mean, Radley, you addressed the communication issue, and I agree that's very powerful, but what about, let's say we have to make a project and we say it has to withstand, the 500-year flood, or whatever number you want to pick, right? The Dutch like 10,000, we might like some lower number. And the fact is that because of sea level rise, we have a fundamentally different kind of uncertainty about what that means than we have in the past. And so even if we could agree on what the price should be, how do we deal with that uncertainty in a framework where we had to come up with a legal reason? Do you have any thought on that, Michael?
I think that's a policy choice that the government is going to have to make, and so far the government is really good at dodging that. And so the natural, I think, of the policymakers is to say, you're the scientists, you tell us what the risks are, and they are not especially good at dealing with uncertainty ranges. Yeah,
so that's right.
So if I could just add to
Please,
that,
yes, Lisa.
And as the globalizer, I think that one thing that's often not considered, especially if we're talking about regional sea level, is the fact that we do have very large-scale, global-scale variability that happens on 10, 20, 50-year time scales that's independent of, well, presumably independent of man-made climate change. And that leads to very large-scale changes in the winds, and the winds are affecting local sea level. So those decadal changes in particular locations could amplify our expectations from climate change, or could actually moderate them over some multi-decade period. And so, this is changing then the timeline of expectation. It's then also potentially impacting the evaluation of adaptation measures that are being taken in coastal areas, which often have to be evaluated within the time span of a political administration. So all of these things are part of the uncertainty that that societies and decision makers face.
Okay, so I know we want to leave time for questions, but there's one more that I want to ask, and I'm interested to hear anyone on the panel's response to this. But we should all try to be brief so that we can have some time for questions from the audience. And this is something that's come up in many things that all of you have said, is the tension between adaptation and mitigation. So if we have an awareness, at least in some places in the world, some places in the country, that climate risk and weather risk are important. There are the two components to that, and I know Dan mentioned them both in talking about the city's response. One is reducing carbon emissions, 80 by 50, or these very important target that the city has reached, and that in some sense is global citizenship. That's doing our part. because our carbon is the same as everybody else's carbon. But then there's adaptation, which is getting ready for the changes that are coming, that in large part we can't do that much about as a small region. And are those things, is there a competition there? In other words, is there a tension, politically, but we only have so much environmental awareness and we have to choose what we're going to do? Or do they complement each other? Does that play out differently? How does that play out in projects in other parts of the world where people are concerned about climate change, but also about what's going to happen to them in the next 5 years? I'm interested in anybody's thoughts about that, the tension between mitigation and adaptation. So please volunteer.
I think that more attention to adaptation can spur more mitigation measures. I think to the extent that people become aware that this is a problem not only many thousands of miles away, but here, they become more motivated to take actions to try to reduce the impacts. And so one of our focuses at the Sabin Center for Climate Change Law is to try to use legal techniques to try to spur more adaptation measures. And there are two reasons for that. One, why we want to do that. One is that people need to adapt. All the projections that we hear from the New York City panel and so forth are for very serious conditions going forward. And secondly, to the extent that the political structure is at some point released from the grip of the fossil fuel interests that are inhibiting rational action, and we have the leaders of major enterprises and major corporations understanding that climate change will have a bad effect on them, on their businesses, that may spur legislation and policy change to have more mitigation. And so Radley and I and our group worked together on a case with Con Ed to try to have them think about the future climate risks, and it was very successful. Con Ed is run by engineers, and they began to really understand the scientific information presented to them, and so they have agreed to utilize the latest science in their planning going forward. And I think that may also mean that Con Ed may be more favorable toward mitigation measures. So I think that adaptation and mitigation really have the potential to work very closely together.
Anyone else like to say something about that?
I think we've heard it a lot in the city that as we think about the conversation change to resiliency as the potentially the latest buzzword around climate change and adaptation taking over, that it was going to be we were ignoring mitigation. And I think it's important to tell everybody it's not either or, it's both. We've already locked in certain changes to the climate from our past behavior and emissions, and we need to be ready for that, and we need to continue to adapt our city. But the story isn't written in yet for what the future is going to hold, and so we also need to continue doing the work to reduce our emissions. And that's where New York's position sort of comes into play, is that we may account for only a small percentage of the global carbon emissions, but if we can show how it can be done, other cities can take that charge, and hopefully nations can come together and actually agree on something that, an agreement that can actually change the paradigm on how we, interact with our own atmosphere and our climate. So I think it's really a bit of both, and we need to prepare ourselves as a city, and for all the vulnerabilities that we have, we know that what Sandy itself was a $19 billion damages and loss events. Climate change alone and our projections into the 2050s could show that same Sandy storm could be a $90 billion event. We're motivated to act. We have to buy on that future risk. But we also have to make sure that risk doesn't continue to grow out into the future. And that's why we need to continue to reduce our own emissions and show the world how emissions reductions can happen so that we can all do it together.
Maybe just to sort of quickly state some of the obvious points, to highlight the scope of the challenge, both in terms of mitigation and adaptation, just how far we are globally from getting on the trajectory that we need to get onto to have a hope of reaching a 2 degrees Celsius warming target. I mean, we're still in the phase, not just of having greenhouse gas emissions going up, but they're still accelerating, right? We have to get off of those trajectories onto trajectories of actually decreases in emissions, not even a stabilizing of emissions. So the mitigation challenge is huge. The adaptation charge also is huge. Probably New York City is one of the best positioned cities in terms of having embraced the risk having financial resources available for a variety of reasons, being able and willing to talk about that risk. But there's so many parts of the world that don't have some of those resources in place, and that even have greater physical vulnerabilities too, places that maybe where the land is sinking dramatically, just to give one example. So both the mitigation and adaptation challenges are huge. That can cause people to lose hope, but it also suggests pragmatically that there are a lot of actions we can take right now. We can focus on some of those areas where there's intersection between mitigation and adaptation. Energy efficiency, which both reduces emissions and reduces the risk of blackouts during times when people are most vulnerable to extreme heat, for example, or green energy actions that make sense in terms of reducing the amount of air conditioning that's needed and capturing some carbon. So I think we can highlight a lot of sort of win-wins in terms of mitigation and adaptation, although we also need to be cognizant that they don't always complement each other. There are some fundamental places where they can operate against each other.
You want to have a last globalizing word on that, Lisa?
Sure. I really agree with what Michael was saying. I think that as our awareness of our vulnerability to climate increases, we start to do something about it. It really motivates people to do what they can to reduce those risks in the future. Extreme events are a great teaching moment, gets people's attention. The fact that climate change is likely to increase the frequency of extreme events, that's one of the more solid outcomes from the models, from the projections. And so getting people to become better prepared, better adapted to those extreme events is really critical. We're not, as we saw, we've kind of come a long way, but we're not adapted to the current climate. And so the more that we become aware and prepared for the current climate, incrementally builds us adaptation for the future.
Wonderful. Okay, so we want to open it now for questions from the audience. There are 2 microphones, one on either side. So if anyone would like to ask a question, please come to the microphone. And we're going to ask that you please ask questions rather than give an additional presentation, and keep them as brief as you can so that other people have a chance to do so as well. And we'll try to alternate the 2 sides. Yes, sir.
Hi, how you doing? I wanted to kind of get the take on the definition, or at least kind of the philosophy of resilience from the panel. I kind of feel like there's probably different aims and goals in terms of resilience, and given that we have kind of a local to the global and the legal policy, I just kind of want to get a sense as far as, what is the kind of metric, or what is kind of the end goal as far as, achieving resilience?
Excellent. What is this buzzword we call resilience?
I guess I should take that since I held the title of Director of Resiliency.
Came to the right place.
Right. I think fundamentally, I guess it's 2 things. It's reducing our risk, and it's making sure that we can make the right investments to reduce risk, and that when things happen, we're better able to absorb them and recover more quickly. And it's to both, extreme shock events, but it's also about, chronic stressors. And, maybe the example there is that, there's coastal storms, but there's also sea level rise. 2 very different stresses. And then there's also, heat waves and increase in temperature and precipitation. But then it can also, this can also broaden beyond climate as well. And whether it's, acts of terrorism or economic downturn, there's a number of different things that hopefully we're also making, as we're making investments in our climate, we're also considering those things. And, whether it's our emergency preparation, we can take that into account. But to me, it's those fundamental things. It's reducing the risk up front, but then being able to recover more quickly. And there's 2 ends of investments that really are able to come out of that sort of thinking or philosophy.
Okay, how about on this side, ma'am?
Hi. What we see, and I know that the focus of this event was more on Sandy, but what we see, and you mentioned it before, is that we have a widespread and different numbers of disasters related to climate change. So now, recently, I think yesterday, on the New York Times, we saw a really interesting piece on the Boston case and what's happening now with the blizzards and all that, and no one mentioned anything about those current events that happen every year, and they're becoming more intense, such as droughts in the Southwest. And so, how is everyone prepared for that to affect New York? And for example, if a storm like that or if a blizzard like that hit New York, would we be as vulnerable as Boston is right now? And how do you get prepared for multiple disasters related to the climate? I know that Lisa mentioned that we are not really prepared for the climate that we have right now, but what kind of initiatives kind of take care of this multiple events and circumstances?
You mean multiple events happening right on top of each other?
Yes.
Who'd like to answer that? Want to do who wants to answer New York versus Boston?
That's fun.
I think that's Dan again, maybe.
Yeah, I think that's probably me. Now we'll leave Boston out of this. I guess there's a few answers to this. I guess one is that we've continued to be, we've gone through a lot as a city, and we've learned from every one of them. Whether it's it's shutdowns of the transit system, or it's blackouts, or it's acts of terrorism, or it's economic downturn. We've continued to learn and continue to get stronger, and you could probably take that back, many decades, and we've had lots of storm events, and we've learned a lot from that. So the city infrastructure here, I think, is well prepared for a wide range of things. We were clearly not as well prepared as we could have been for Sandy. And then, when you look into the future and what Sandy might have been, and had it not hit in late October, but it had it hit during an August heat wave, is kind of truly frightening around the sort of impacts that could have had on people. In many vulnerable situations, the power goes out, it's 100 degrees out, those sort of impacts. So that's why we try to find those investments that can address multiple challenges, and that's why working with Con Ed, and the point you make Michael, about Con Ed actually adopting the climate projections into their planning process, like something like that is incredibly important. They didn't just say, well, Sandy hit us to this level of water, therefore I'm going to build everything to that level and then move on. They're actually, it was a very cooperative collaboration with Con Ed to be able to look at the future climate projections and build that into their process. We're never going to be fully climate proof, I think you made that point, but I think what we could do is continue to be climate ready and continue to talk about the risks. There's a long-term conversation that's happening about what these risks are going to mean to the city, across the next century, and we're continuing to put things in place in order to reduce that risk. Will we never be surprised? I don't know if I could say that, but I think we're going to continue to broaden our aperture on what those risks are going to be, and put in place the right programs to reduce that risk.
I want to say something about the science part of that question. So Boston blizzards are interesting because it's not one storm, it's a whole bunch of them, and a lot of the harm is coming from the fact that the snow's piled up and hasn't melted, so that's breaking people's roofs, it's making the streets impassable, it's shut down the subway. Had it just been 1 2-foot snowstorm, they would have been in a lot better shape. So I think this brings back to something I wanted to say about the Columbia Initiative on Extreme Weather and Climate. That has 2 meanings, and that's intentional. One is extreme weather, and climate is how climate influences the probability of an extreme weather event. But then there are some extreme events that are not really extreme weather events, but are extreme climate events in that they last a long time. They take a long time to happen. So that's the definition of climate, right? So a drought is an extreme climate event because by definition, it isn't a drought unless it doesn't rain for a long time. This event in Boston is a climate event, and that it's multiple storms happening over a season. And one thing I think that's important to say about that is that we have almost no ability to predict those events ahead of time on the right time scale, which would be a seasonal time scale. If someone were to ask, is the next season going to be extreme? There's no seasonal forecast can really tell us that unless there's a huge El Nino or something, which there wasn't this time. Whereas I think on the weather side, we take for granted, our forecasts have become so good, and we saw this in Sandy, that we almost take for granted that a few days ahead of time we're going to know if there's going to be a big storm. But a big burst of them, we have no ability to predict on the time scale of the event itself, which is longer than a single storm. So I think there's a science challenge there as well as a policy challenge. But why don't we go to the next person on this side?
And thank you for being here. I have 2 quick questions directed to Mrs. Shirley. The first one is, can you please speak to why we continue to develop in floodplains here in New York, and why we shouldn't, or what special considerations we should take? And then secondly, if you can speak directly to some of the affordability strategies you're thinking about in terms of the insurance that you mentioned. Thank you.
Sure, and thanks for those questions. Developing in floodplains definitely continues to come up as as a topic of conversation, and you know, from the city's point of view, if you were to look at what happened during Sandy, just as one perhaps example, the most recent construction, even on the coastline, was the safest place to be. And I think it's been well documented around the development on the Rockaway coast called Arverne by the Sea. It was just built a few years ago, but it was built to the most recent building code standards. It was elevated, it had a great drainage system, it had dunes built in front of it. It was sort of a model for what can be, and it highlights that it's not necessarily should you develop the waterfront or should you not. You can do it in a smarter way, and you can take into account the risks, and you can think about the lifespans of the assets you're developing and make wiser choices about how we engage with the waterfront. Honestly, our real challenge is everything that's already in the floodplain, much more than it is about what discrete projects may go there in the very, in the future. And we saw that bear out in the statistics from the storm itself, where of all the damage that we saw, it was those bungalow communities that were on the coast, the one-story timber frame, probably barely connected to their slab foundation, that were absolutely destroyed. And and none of those were built to anything like a modern building code. Whereas whether it's what was built on the Williamsburg Greenpoint waterfront, or things like Arverne by the Sea, or even going back further of Battery Park City, buildings to the most recent building code are naturally going to be more resilient and safer because they're built to those modern standards. And we're continuing to look at what those standards should be. We're upgrading the code already for future sea level rise. We're looking at our zoning code and making sure that we can continue to incentivize better structures that do exist in the floodplain. Now, the flip side of that, of course, is the pricing of risk and what that means. And so by building to those most recent standards, that is naturally building to those highest standards as they account for flood risk pricing. And so new structures need to take that into account if they are going to be built, and so make those investments. But on the affordability side, again, this is an existing building challenge. Most of the structures that were built in the floodplain across the city are pre-1983. That makes them what we call pre-firm. They existed before the flood insurance rate maps were put into effect, and they don't meet anything like a modern building code, which is part of the reason why Congress, when they did institute flood insurance, accounted for that grandfathering of the subsidies that were built into the code, with the idea, I assume, that buildings were naturally going to turn over time and be built to the most recent standards, and therefore the subsidies wouldn't be needed. That hasn't quite borne itself out in the same way, just because of the politics around what those rates do. But the things that the city's doing, first and foremost, we're acting to reduce the risk, and that's both on the individual structures, and through our housing recovery program, we're going to end up elevating thousands of homes across our floodplain to make them more resilient. But then there's also neighborhood scale things. We're putting a lot of investment into our coastline, a $3.7 billion coastal protection plan that continues to move forward to reduce that risk. And then separately, there's a range of things that we're working with FEMA on to advocate for a more rational assessment of risk reduction. To FEMA, it's all or nothing. You meet the highest elevation of the base flood elevation for a building, and you get the least priced premiums. If you don't meet that elevation, you get hit with an elevation-based premium charge. But there's no other consideration for moving your mechanical equipment up, or doing things on multifamily buildings that can't be elevated and probably shouldn't be elevated, but they can be made more, their risk can be reduced by taking other measures than just elevation. So it's a range of sort of premium credit for, or partial credit for partial mitigation actions, and it's also about making sure that we're making the right investments across the coastline and in individual buildings. So it's a range of things.
Okay,
hope that helps.
Just time for one or two more. Yes, sir.
Hey, so I'm from the architecture school, and so we've been studying a lot of the rebuild by design proposals and then kind of proposing our own things. And so just specifically in response to the Bjarke-Ingels proposal for Lower Manhattan, I'm wondering, what do you guys think that project got right? And what do you think are some things that maybe it didn't address or couldn't address that you think should be addressed in the future?
No, it was a great partnership. So the city initially, in its coastal protection plan, identified a couple key targeted areas where we wanted to see improved coastal resiliency, and one of those was in Lower Manhattan, and particularly on the Lower East Side. And so when the Rebuild by Design competition started, we were thrilled to work with the teams, to work with HUD, to ultimately get ourselves to a place where those sort of proposals and we're able to move forward. The Bjarke-Ingels team was, did a great job of working with the community to get a lot of stakeholder input to continue to advance that idea to the point where it could be funded. And the city has been awarded $335 million. It's one of the key elements of our plan going forward, and amongst a number of other investments we're making around the city. But in the Lower East Side in particular, we've got the $335 million. We are really looking at this as a piece of flood protection infrastructure, but something that does not inhibit our ability to enjoy our waterfront. And so finding ways so that flood protection doesn't feel like flood protection and is useful when you need it, but is serving other purposes, and whether that's topography within part of the park that can be enjoyed on non-flood days, or any number of other measures that we're pursuing. I think it's really important that we not wall ourselves off from the waterfront. We are a coastal city. We've always been at risk. We need to make ourselves less at risk to those types of events, but we can't just wall ourselves off from the waterfront. And so the challenge is really to make sure that we can continue to engage with the waterfront, be able to access it, but reduce our risks on those days when we can. And that's something we're very much pursuing through the Rebuild by Design Awards in the Lower East Side, certainly in Hunts Point, and in partnership with the state in Staten Island as well.
Okay, last one on this side.
All right, I hope it's a good one. A fundamental lack of causality between the specific and individual extreme weather event and climate change. And I'm curious as to how long you think a series of events or a trend of extreme events is necessary to solidify the causal nature of climate change and extreme weather. When can that be a more accepting discourse than now, when a like Sandy comes? Many say, yes, this can very much be a result of climate change, and on the opposite end, you can't pinpoint one specific event.
Right. You want to answer that?
Sure. So it depends on a lot of factors, certainly. It depends on the type of extreme event. If we're talking about something where there's a lot of natural decadal variability, something like extreme precipitation events or even annual precipitation at a scale, it's quite possible that many regions, wouldn't have a climate change signal emerge even within 100 years. For other variables, though, like global average sea level rise, even regional sea level rise, global average temperature, by the time we get out a couple decades from now, if that, probably the signal will emerge, or in some cases already emerging, relative to that natural variability. Other things to think about here in general are it's always better to focus on a larger region and a longer time period if you want to find those types of signals. Other critical pieces include the role of climate models, their ability to reproduce some of these types of events, which they can do better for some events than others, because using climate models, we can build an artificially long data record to work with. On the other hand, there's always the question of how well those climate models are reproducing what we're actually observing. So those are, I guess, a few of the pieces.
Yeah, I mean, we used to always say that you can't attribute any single event to climate change. That's not exactly true. You can make probabilistic statements, and you can say that this such and such percentage more likely. And the way that you do that, as Radley said, is if you have a good model of the physical system, you run it for a long time in the current climate scenario with the right amount of greenhouse gases we have today. You see how often the event happens, and then you run it in a pre-industrial climate without that greenhouse gases, see how often it happens then, and the difference in the probability of the event is attributable to human-induced climate change. Now, that only gives you a clear signal if you have a good model that can simulate the type of event you have, that the natural variability isn't too large compared to the global warming signal, and et cetera. So you can only make meaningful statements about some types of events. Heat waves, I think already we're seeing an anthropogenic signal that's detectable above the noise. So the 2013 Australian heat wave, there were several studies coming to the conclusion pretty strongly that it was significantly, by several-fold, more probable because of a human influence. Other events like hurricanes, the models aren't good enough and there's too much natural variability to make those kind of statements. So it really is an important research question. At the same time, I think we shouldn't pin our we shouldn't pin whether we take climate change seriously or not on whether we can attribute each weather event. We really have to get past that. We have to understand that, that some events are becoming more probable. Sometimes we can say that, sometimes we can't even say that yet, as in the case of tornadoes, for example. But nonetheless, we know that the Earth is getting warmer. We know some of the risks that are there, and that's got to be enough. I don't think we should focus on whether each individual storm can be attributed to climate change quite as much as we do, even though I think we also, those of us in this business, have to recognize at the same time, just to contradict myself, that that real events are what get people's attention, as I think Lisa said. I mean, we're human beings, and we're drawn to pay attention to real events and real stories. So I think we have to, at the same time, understand that.
So maybe one thought, and Bradley, I think you've made this point well in terms of whether or not we can attribute Sandy to climate change. What we can attribute to climate change is the fact that we've had a foot of sea level rise over the last century, and had that not happened, the flood elevations that we saw all over the city would probably have been a foot less. And that's meaningful when we're seeing flooding get over natural levees like Father Capitano Boulevard in Staten Island, or other places where that extra foot may have made a difference, whether that example is true or not. But I mean, that foot makes a difference, and that foot is clearly attributable to the climate change that we've already seen here in the city.
Yeah.
But in terms of preparedness and resilience for any location, right? If you're actually talking about keeping people safe, it's the whole spectrum of climate that we need to be concerned about. I mean, one thing is making a case for mitigation, broad adaptation efforts because of man-made climate change, but you really want to know for a location, what are all of the factors that are leading to extreme weather? And if climate change is making those worse or more frequent, that's an important part of it. But for any specific event in a specific location, being able to provide accurate information because you're including all of the factors that are influencing that event is really critical. Okay, so I think with that, we're out of time. I just want to say a couple of things. I want to, first of all, thank the Executive Vice President for Research, the Earth Institute, and Lamont for sponsoring this event. I want to thank everyone, all of you for coming, and especially our panelists for coming to speak on this issue. This is going to be just the first of a series of events. Maybe not all maybe not all of them will be this in such prominent locations as this, but we hope that this will be the start of an ongoing series of discussions on this topic, broadly speaking, not just Sandy, but extreme weather and climate and all the societal dimensions of that within the university, and involving as many interested partners as we can. So I encourage you to participate in all of that as you have tonight. So thanks everyone for coming, and good night.